Um, so this is the first question from section A of the 2025 West African Senior School Certificate Examination. That is what we popularly call WAEC. And the question is basically on sets, which is one of the most important topics in mathematics for senior secondary school, precisely. So the question reads that given that mu is equals to x such that x is greater than 1 and x is greater than 20, where x is an integer, and p is equals to x such that x is a multiple of 3 and q is x such that x is a prime number, where p and q are subset of mu, which is the universal set. You have to find all these terms here. So basically, this term I called mu is usually used to represent universal sets. So I believe people listening to this video are not that new to sets. And even if you are new, so what we call a universal set is just a set from which we obtain all these other sets. So every element are going to be seen in P, and the ones that are going to be seen in Q, they are obtained from this universal set. That is why we call this a universal set. That is why you see here they said P and Q are subsets. Subsets means P and Q are removed, are obtained from this universal set. So that is basically what this statement subsets means. So the first thing we are going to do is to list out the elements that are in the universal set. So for my solution, so I will list out the elements in the universal set. So that is mu equals to. So as I mentioned, I believe you are not beginners, and even if you are, so please try to note that in sets, whenever you are trying to list out the elements, it is compulsory that you put your elements in the brackets. So you may use a square bracket or curly bracket as I use here. So anyone is okay. But it is wrong for you to just write the elements in your set without putting them in a bracket. So you open your curly brackets. Now you have to be very careful here. So we are given that the elements in this set, there are some instances where you'll be given sets, the elements in the sets directly. It should not be written in form or inequality this way. But here you are expected to extract the elements in this universal set from this statement. So the values of x, they are numbers that are greater than 1. So and this, you have been given a boundary condition here that those numbers must be integers. All we call integers are whole numbers, whole numbers. So integers could be positive or negative. But here you have this condition here. So where x is an integer, it means whole number, meaning you cannot have a decimal number here. You cannot have 1.2 and the likes. Now, integers that are greater than 1 will have to start from 2. So you notice I did not include 1 here because this statement reads x is greater than 1. So if it is in a case where you have a line under this sign, so that will read x is greater than or equals to 1. In that instance, you have to include 1. So if this was x greater than or equals to, it means you have to start from this number here. That is when they put a line. Just one of the equal, your equality sign has 2 lines. So if they put one of it here, it means you have to include a number here. But this one is showing that it is strictly greater than 1. So you start from 2. So 2 is the first integer, first whole number that is greater than 1. So then you continue until you reach, so you are supposed to stop on 20. However, look at what you have here. They say x is less than 20. So the same thing I said here, you are not going to be including 20. You stop on the integer, the whole number that is less than 20, which is 19. So same thing I mentioned here, if this was having an equality sign under it, if it was x less than or equals to 20, you will have included 22. So you have to watch out for that when you are solving questions. So there are times where you have things like that. So the universal sets will comprise 2, 3, 4, 5. I don't want to write everything up until 19. That's I can just continue on 18, 19. I'm just trying to tell you that I've skipped some numbers here. So I have 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 19. And I think I already mentioned the reason I did not include 20. So this is the universal set. And something you notice is that the elements in P are the elements in Q. They will be obtained from this universal set. So we've listed at our universal sets. And as I mentioned, you notice that my sets are included in a bracket and each of the elements are separated by a comma. So that is a rule you must follow in sets. So the moment this bracket is absent or assume all you have written is just a list of numbers, not a set. Now, for the elements in P, now they said you have a bracket again. They said it is x such that x is a multiple of 3. We have many multiples of 3. 999 is a multiple of 3, 666 and a lot of them. But since we have been told that P and Q are subset of this element, it means we are only going to be including the multiples of 3 that are inside the universal set. Remember, I told you that subset means we are removing the elements in P and those in Q from this universal set. So once we remove the numbers here that are multiples of 3, so those will be the elements of set P. So what are multiples of 3? It means you know your multiplication table 3. 3 times 1, 3. 3 times 2, 6. 3 times 3, 9. So 3, 6, 9, 12. So and so on like that. Their elements are they are multiples of 3. So in here now, the first multiple of 3 we have is 3 itself. So 3 is the first element you have in P, followed by, 6 is part of it. I don't write it here because I don't want to waste much space. So we have 6, we have 9, we have 12, we have 15, and we have 18. Normally I'm supposed to continue. You're supposed to have 21 and the likes. But remember, I told you that the elements in P must be obtained from here. And since this does not get to 21, so we'll stop on 18, which is the last multiple of 3 we have here. So these are the elements in P. So you have 3, 6, 9, 12, 15, and 18. Then for set Q, so let me come to this next line. For set Q, so they said the elements in Q are prime numbers. Prime numbers. So the elements in P are prime numbers. So I have to obtain the prime numbers in this universal set to get the elements in Q. Now, what are prime numbers? So you must be very careful here so that you don't make mistake. So there is a mistake students always make as regards prime number, and that is considering what is the definition of prime number. So basically, for a number to be qualified to be called a prime number, it must fulfill 2 conditions. One is that it must have only 2 factors only. Only 2 factors. Sorry for that repetition. Only 2 factors. So what we mean by factors is number that can divide a number. For instance, now 10 has 1 as a factor because 1 can divide 10 without remainder. 2 can also divide 10 without remainder. 5 can divide 10 without remainder. 10 can also divide 10 without remainder. So 10 has 4 factors. So meaning it is not qualified to be called a prime number. So a number that is qualified to be called a prime number needs to have only what? Only 2 factors. And those 2 factors must be 1 and itself. A prime number has 2 factors. That's the first condition. And the 2 factors must be 1 and that prime number itself. So those are the 2 conditions. So if any of those 2 conditions is not met, then such a number is not going to be a prime number. Perhaps it has more than 1 or more than 2 factors, or it doesn't have up to 2 factors, as the case may be, then it is not qualified to be called a prime number. And that is what brings me to this. Now, though 1 is not included here, so we don't have any much problem. But 2 is a prime number. Many students keep 2 as a prime number. Most students think 1 is a prime number. But 1 is not a prime number because 1 has just a factor. That is 1. Remember I said before a number is qualified to be called a prime number, it must have 2 factors. That condition must be met. 2 and it should not be more than 2. So 1 has only 1 factor, which is 1 itself. Therefore, 1 is not a prime number. 2 is a prime number because the only two factors of 2 are 1 and itself. That's 2. So 2 is a prime number. Why 1 is not? So there's a difference between prime number and even number and odd numbers. So that is just what you have to take note of here. So the first prime number we have here is 2 because 2 has only two factors, 1 and itself. 3 is also a prime number. 3. 4 is not a prime number because the factors of 4 are more than 2. 1 is a factor of 4. 2 is a factor of 4. 4 is also a factor of itself. So it has 3 factors. So that disqualifies it. It is not a prime number. Then we have 5. 5 only has 2 factors. That's 1 and itself. Then we have 6 is not a prime number. Then 7 is a prime number. 7. Because the only factors of 7 are 1 and 7. 8 is not. 8 has 1, 2, 4, and 8 as its factors. 9 is not a prime number because the factors of 9 are 1, 3, and itself 9. So it has 3 factors. And remember I said a prime number must have only 2 factors. Then the next prime number, 10 is not. Then 11 is a prime number too. So let's not waste time. Let me just write out the remaining prime numbers. 13 is a prime number. 17 is, and likewise 19 is a prime number. So these are the prime numbers we have in this universal set. So these are the prime numbers. Every other numbers are not prime numbers because they have more than one factor. So we have already written out the elements here. Then we can now go to what we are told to find. So in some instances, in some questions, you will have been given all this. So they just ask you these questions, and those ones are more straightforward. But here, you are supposed to obtain your elements yourself. So the first thing we have here is that we should evaluate P. Now, in sets, so basically, the relationship we have between sets, they are actually more than 2, but the common ones are, you have to note this. You might be familiar with them before. So this symbol is called union. Union, just like letter U. Why this symbol? As if you just inverting this, like it is called intersection. Intersection. So union of two sets means you are merging the two sets. So union. So what do they call marriage? Union of a man and a woman. So when they come together, as you will say. So that is a union. So when you merge two sets, when two sets come together, that is what we call union. Then intersection is basically what is common to two sets. The elements that are common. That's what we say two lines intersect. It means they meet. So where two what's it called? Two sets meet. So what's the elements that are common to two sets are what we call intersection of two sets. So try to take note of these two symbols. And you notice that what you have here is P intersection Q prime. Now, things you have to take note of here, I already talked about what intersection means. Now, what do we call prime? This is called prime, and in some cases, you will see it written as Q complement. They actually mean the same thing. Come on. They mean the same thing. So it's, in some cases, it is written as Q complement, as if you have Q raised to C. So you get to know what complement of a set means soon. So either it is written this way, it's written as Q prime. So though this is more common, Q prime is more common. So they both mean the same. Now the first thing we have to do here is, we know Q, but we never knew Q prime. So the first thing we have to do is to find Q prime first. And what does Q prime mean? Q prime means there are some elements that are in the universal sets that are here, but they are not inside Q. That's what I mean by Q prime. So when I say Q prime, I mean you should find the elements that are in the universal set, but are not present in Q. So those are the elements. That's what we call Q prime, or complement of Q, complement of a set. So the elements that are in the universal sets but not inside Q, they are 2 is here, 2 is here, so it is not part. 3 is here, 3 is here. 4 is in the universal set, but Q does not have 4. So the first element you are going to have is 4 for Q prime. 4. They both have 5, but the universal set has 6. Remember, we just kept those ones, but Q does not have 6, so include 6. 7 is present in both. 8 is not here, so you include 8. Remember, 8 is going to be in the universal set. 9 is not here, you include 9. 10 is not in Q, you include 10. 11 is there, so you don't include 11. 12 is not in the universal, it's not in Q, so you include 12. 13 is here, 14 is not there, 14. 15 is not, 15. 16 is not, 16. 17 is there, so you don't include 17. Then the last element in Q prime is 18. So these are the elements that are in the universal set, but they are not in Q. So we have 4, 6, 8, 9, 10, 12, 14, 15, 16, 18. So these are the elements that we call complement of Q. So it means it is this element that will complement this Q to make it to be equal to this universal set. That's what it tells me. So that's what we call complement of a set. Now that you know Q prime, you can now find the intersection between Q prime and P. Remember, you already know P. This is set P. So P intersection Q prime. Remember, I told you what intersection means earlier. An intersection means what is common to both P and Q prime. And what would that be? So you check P and Q. If you like, you may write the elements there again. So I will even prefer to do that so that we don't make mistake. So the elements in P, write them out. These are the elements. We have 3, 6, 9, 12, 15, 18. So those are the elements in P. Then intersection Q prime, we have this element 4, 6, 8, 9, 10, 12. I hope I don't make mistake. 14. So you have to be very careful here so that you don't skip any elements, especially when you are writing the exam and you have that tension. But then it's something very straightforward anyway. So P intersection Q is going to be, now we have to watch out for the elements that are here and here. All you have to just do is just focus on this first element. Check an element here and see if it is here. That's all you have to do. 3 is here. Is 3 here? The answer is no. So it is not a common element. 6 is here. Is it here? The answer is yes. So the first intersection is 6. 9 is here. Is it here? Yes. So include 9. 12 is here. Is it here? Yes. Include 12. 15 is here. Is it here? The answer is yes. Include 15. This is meant to be 18. Sorry. Yeah. P is 18. So this is meant to be 18. So 18 is 18 is also common to the two of them. So this is 18 and this is 18. So we include 18. So these are the elements in P intersection Q prime. So you have 6, 9, 12, 15, and 18. And if you check, you notice that those are the two elements. Those are the elements that are common to the two sets. So that's for the first question. Then the second one, that's question 2. We have to find P prime union Q. Remember I said this symbol represents union. So it means you have to match the elements in P prime and Q. You know, we already have set Q. This is set Q, but we don't have set P prime. So we have to find that first. So the same way we found Q prime is the same way we are going to find P prime. So P prime means the elements that are in the universal set, but they are not in P. So you have to check what are the elements that are not here, but they are in the universal set. So the elements are, the first one I can see here is 2. 2 is here, but it's not here. So you have 2. This one has 3, so you don't include 3. It doesn't have 4, you include 4. It doesn't have 5, you include 5. It has 6, so you don't include 6. It doesn't have 7, 8, include 7, 8. It has 9, so you don't include 9. It doesn't have 10, include 10. It doesn't have 11, you include 11. It has 12, so you don't include 12. 13, 14, it doesn't have, so you have 13, 14. 15 is here, so you don't include it. 16 is not here, 17 is not here, so you include 16, 17. 18 is here, you don't include 18. So then the last one is 19. 19. So these are the elements in P prime. So again, P prime means the elements that are not in P, the elements in the universal sets that are not in P. That is what P prime means. So we have these elements 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, 19. So these are the elements in P prime. Now that we have P prime, we can now find P prime union Q. So that is going to be equal to, this is P prime. So I said this, rewriting it is optional, but I think it is fine so that I don't make mistake. By the time you place them side by side as you have here, it is always very easy to compare them. Either you want to find the intersection or the union. So you have P prime is 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, 19. I hope you can see my handwriting. Then union Q. Q is here. Okay, here we have 2, 3, 3, 5, 7, 11, 13, 17, 19. So, and as I mentioned earlier, so the union of two sets means you are combining the two sets together. And something you must note about combining is that you combine without repetition. So you are combining, you are merging the elements here with the elements here. So in a case where an element appears in the two sets, you only write it once. So in union, there is no repetition. So you can see this, we have 2 here, we have 2 here, so you write 2 just once. Please note that you must not repeat what's common to the two of them. So 3 is in this set, but it is not here, so you still write it. So the point is, at least one of them should have it, should have that element before it can appear here. So if those one has it and this does not have it, it is fine, you include it. If both of them have it, you write it just once. So there must be no repetition. Note that. You have 3, this is 4, 4, 5, both of them have it, so you write it just once. 5. Neither of them has 6, so you are not including 6. So 6 is not here, it is not here. So 7 is here, both of them have 7, write it once. 8 is here, 8. 9 is not here, check if it is here. It is not here as well, so you don't write it. So 9 is not there at all. 10 is here, 10 is here. This does not have it, but it doesn't matter, as I said. 11 is here, you write 11. 12 is not here, check if it is here. It is not here as well, so you don't write it. 13 is here, so it doesn't matter if it is in the other one or not, just write it. 14 is here, 14. 15 is not here, we'll check if it is here. It is not here, so we'll leave it out. 16 is here, 16. 17 is here, 17. 18 is not here, we'll check if it is here. It is not here too, so you skip it. 19 is in both cases, write it once. So these are the elements in P prime union Q. So we have 2, 3, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, 19. So that is P prime intersection Q. Then the last question is that we should find C, which is P union Q prime. So when you have a question like this, when you have an operation included in the bracket here, so the first thing you have to do is to find what you have in the bracket here first, before you talk about the complement, the prime. So the first thing I'm going to be doing here is to find P union Q. And I think you already know, sorry for this, you already know what P union Q means. So it means I'm to match the elements in P and the elements in Q together. So I will, as I've always been doing, I'll put them side by side first. The elements in P are 3, 6, 9, 12, 15, 18. While the elements in Q are 2, 3, 5, 7, 11, 13, 17, 19. So these are the elements in P, these are the elements in Q. So merging the two of them together, so that's union. Remember, we have union here. That is the same thing we just did up here. So P union Q, the elements in you merge the elements in the two of them. 2 is here, so it doesn't matter if it is in the other one, write it 2. 3 is in both, write it once, 3. Neither of them has 4, you don't write 4. 5 is here, 5. 6 is here, 6. 7 is here, 7. 8, none of them has it. 8 is not here, 8 is not here, so you skip it. 9 is here, 9. 10, none of them has it. I think, yeah. 11 is here, 11. 12 is here, 12. 13 is here, 13. 14 is not here, it is not here, you skip it. 15 is here, 15. 16 is in neither, so you skip it. 17 is here, 17. 18 is here, 18. Then 19 is here, 19. So the elements in P union Q are 2, 3, 5, 6, 7, 9, 11, 12, 13, 15, 17, 18, 19. So that is P union Q. All you have done here is just what you have in the bracket. Then you can now take their complements. That's the prime. So this is P. This is P union Q. Now P union Q prime will now be. I think you can remember how Wallace take prime. You can maybe you pause the video and try it. Prime is the elements that are in the universal sets here, but they are not inside P union Q. So there will be very few of them because almost all the elements are here. But definitely there will be some. So this is going to be now 2 is here, it is here. So 3 is here. So all you have to do is it is very simple. Just follow these numbers. Though the elements in the universal sets are from 2 to 19. So check these numbers. Any number from 2 to 19 that is not here will be in the complement. So 2 is here, 3 is here, 4 is not there, so you include 4 here. 5 is here, 6 is here, 7, 8 is not here, 8 will be in the complement. 9 is here, 10 is not here, 10, 11, 12, 13, 14 is not here, 14, this is 15, 16 is absent, 16, 17, 18, 19. So these are the elements in the complement, so I can just clear this. So the P Q complement is 4, 8, 10, 14, and 16. So these are the elements in this. So there are instances where maybe they ask you to do something and there's no elements. Maybe they ask you to find P intersection Q and you find out that there's nothing common. So we also have answers that are empty sets. So empty sets are usually represented with just open the parentheses and close it. So this is an empty set. So maybe in other examples you are going to see that. So this is all you are required to do in number one. And as a matter of fact, the question is very straightforward. Just because of the explanation, that is why it looks a bit lengthy this way. So you can try to do other questions on this topic and see if you have grabbed the concepts. And if you have any question, do not hesitate to ask under the comment section. Thank you very much. We'll see you later on other questions.